Cyclic compounds, ubiquitous inorganic compounds, are chains of atoms are covalently bonded to form a closed ring. These rings are primarily composed of carbon, but can also contain heteroatoms such as nitrogen, oxygen, and sulfur. In the course of organic synthesis, a chemist often needs to form a new or alter an existing ring. By expanding or contracting an existing ring, it is possible to access structures that would be difficult to nearly impossible with a single cyclization reaction. Ring expansions are valuable because they allow access to larger systems that are difficult to synthesize through a single cyclization due to the slow rate of formation. Classifying ring expansions by the mechanism of expansion and the atom added allows one to see the similarities between different expansions methods and different incorporated atoms. The broadest classification comes by the mechanism of expansion. The rings can be expanded by attack of the ring onto an outside group already appended to the ring, opening of a bicycle to a single large ring, or coupling a ring closing with an expansion. These expansions can be further broken down by what type of atom they incorporate into the expanded ring. Carbon insertions are tremendously useful reactions which introduce an additional carbon atom into the ring. These reactions are used in the synthesis of many drugs and natural products. These can proceed through any of the mechanisms listed above. These reactions have the general features of having an exocyclic leaving group on a carbon adjacent to the ring, and an electron-donating group on the ring capable of initiating a migration of an endocyclic bond. A common migration introduction of carbon is a pinnacle rearrangement. While this reaction refers specifically to a vicinal dihydroxide rearrangement, there are other pinnacle-type rearrangements that proceed through the same general mechanism, such as the Tiffany-Odemjanov rearrangement. These semi-pinnacle rearrangements occur under milder conditions, and are thus preferable in complex syntheses. These reactions are useful beyond simply expanding a ring, because the exocyclic group attacked may also have other functionality appended to it besides the leaving group. The group to which the endocyclic bond migrates can also be selectively added to the ring based on the functionality already present. For example, 1,2 addition into a cyclic ketone. Carbon introduction through the opening of a bicyclic system is a way to introduce either a single carbon or several at a time to the ring. The single carbon introduction often goes through a cyclopropane contouring bicyclic intermediate, which is then opened to give the expanded ring. The expansion can occur either through an electrocyclic ring opening or an induced cleavage of the shared bond. These reactions are differentiated in terms of how the carbon is added to form the cyclopropane ring. A Simmons-Smith-like reaction with an alkene-containing ring can be used to introduce a single carbon. Other methods exist for cyclopropanate other functionalities, such as the Buchner ring expansion for RNAs. The formation of the cyclopropane ring in a single carbon expansion allows the introduction of additional functionality along with the ring expansion, provided the additional functionality is appended to the carbon being inserted. The target of cyclopropanation also varies depending on the conditions used. The Simmons-Smith reaction adds to alkenes, while the Buchner ring expansion allows addition to typically unreactive RNAs. The Buchner ring expansion is useful because it gives cycloheptatrienes as the ring-opened products, which are found in the core of some natural products, such as azolenes. An important consideration in these ring expansions is the ring opening to an expanded ring, and not an exocyclic group on the original ring or an unopenable product. The Buchner ring expansion is encouraged to open to the desired product by placing electron withdrawing groups on the carbon added. In order to perform the ring opening on saturated bicyclic molecules, the cyclopropane must be introduced such that a neighboring group can facilitate the expansion, or the ring must be opened by attack from an outside group.